Today we are going to do few more questions from exercise 13.1. So let us start. First of all, we are having question number 4, and question number 4 is: a cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So you see, let me draw the diagram first. Let us say this is our cubical box. Okay, this is our cubical box. A cubical block of side is 7 centimeter, surmounted by a hemisphere, and we are having a hemisphere. Okay, so the hemisphere will be this is the hemisphere, and this is the base of the hemisphere, right? This is the base of the hemisphere, and this is the top part of the hemisphere, CSF hemisphere, this part. Okay, so this is the hemisphere. So this cubical box of side centimeter is surmounted by a hemisphere. So what is the greatest diameter the hemisphere can have? So you see, the greatest diameter of the hemisphere will be equals to the side of the cube. Okay, if you take the diagonal in any part, the hemisphere will go out of this cubical block. Okay, so that's why the greatest diameter of hemisphere that will be equals to side of cubical block, that is equals to 7 centimeter. Okay, so diameter of hemisphere is 7 centimeter, right? So D, that is 7 centimeter. So radius of hemisphere will be 7/2 centimeter, right? Okay, then find the surface area of the solid. So therefore the surface area of solid, that will be equals to TSA of solid, TSA of cubical block, okay, plus, let me show you, let me write first, plus CSA of hemisphere. You can see this TSA of cubical block, right? Okay, then CSA of hemisphere, which I am going to write. This is CSA of hemisphere, this part, this portion is CSA of hemisphere, right? So let me write CSA of hemisphere, CSA of hemisphere, okay. And we need to subtract this portion, okay, because it is covered by the CSF hemisphere, so we need to subtract this portion, and this is what, this is circular portion, that is the top of the hemisphere, okay. So we'll write minus area of circular base, okay, right. So TSA of cubical block is what? Total surface area of a cube is 6a square plus CSA of hemisphere is what? 2 pi r square and minus area of circular base, that is pi r square, which we can write 6a square, 2 pi r square minus pi r square is pi r square, okay. Putting the values 6 and the a means side of the cubical block, that is 7 centimeter, that is 7 square plus pi means 22 by 7 multiply r, that is 7 by 2 multiply 7 by 2, right. So 7 is cancelled by 7, 2 11 is 22, so this is 6 into 49 plus 11 7 is 77 by 2, and 6 into 49 is what? That is 294. 294 plus 77 by 2 is 38.5, okay. And when we will add it, we'll have what? 0.5 is there, 8 and 4 12, 3 and 1 4, 9 and 4 13 and 2 1 3, 332.5 centimeter square is the area of this total surface area of this solid, okay, right. Okay, now let us take question number 6. Question number 5 is as same as question number 4, so that is your homework. So question number 7 is a medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter, okay. So the diameter of the capsule is 5 millimeter, right. We are having here two hemisphere. What is this? The diameter of one is this one, and you see this one the diameter of the one, and this one is the diameter of the other one, okay. So these two are the hemispheres here, one is this and the other one is this. The diameter is given 5 millimeter. So diameter of hemisphere that is given 5 millimeter, right. So the radius of hemisphere will be 5 by 2 millimeters, okay. Now the total length of this capsule is given 14 millimeter. Total length is given 14 millimeter, right. So you see we say the length of this cylindrical part will be what, or the height of the cylinder, you can say, from this here to here, from this point to this point. So that will be height of the cylinder, right, or the length of the cylinder, right. So height of cylinder, that will be total length of the capsule, that is 14 millimeter minus we have to subtract 5 the radius of the hemisphere from this one, this part, and this. So these both are radius of the hemisphere. So 14 minus 2 into radius of hemisphere, that is 5 by 2. So 2 cancel, 14 minus 5 is 9 millimeter. So we can say the height of our this cylindrical part, that is 9 millimeter. Now you see the radius of the cylinder. The radius of the cylinder will be also 5 by 2 millimeter, right? So because, right? So that is also a radius of radius, right? So I can write here radius of cylinder. Now because radius of cylinder and radius of hemisphere is same, that's why I have used same r, small r for both. Okay. Now what we need to find its surface area. So total surface area of this capsule, of the capsule, that will be equals to see CSA of cylinder, right? So that portion is here, this CSA of cylinder, right? CSA of cylinder, and what we are having, plus what we are having, two hemispheres, one at this end and the other one at this end, the other end, right? So CSA of both the hemispheres, then so we can write plus 2 multiply CSA of hemisphere. Okay, so CSA of cylinder, so CSA of cylinder is what, that is 2 pi RH plus 2 multiply CSA of hemisphere is what, 2 pi r square. As the radius of both the cylinder and the hemisphere is same, okay, that's why I've taken r, right? Now to solve this one, what I'm going to do, okay, I'm going to take common. Let us take common 2 pi r, I can take common here, and then what is remaining, h here, and plus 2 r here, right? And calculating further, what will have, 2 multiply pi is 22 by 7 multiply r, that is 5 by 2, h, that is 9, 2 multiply 5 by 2. Okay, this 2 is cancelled by this 2, so this 2 is cancelled by this 2, so you can write 22 by 7 into 5 multiply 9 and 5, 14. So this is 7 to the 14, 5 to the 10, so this is 220 millimeter square is the total surface area of this capsule, one capsule, right? Okay, now let us take question number 8. So question number 8 is, from a solid cylinder whose height is 2.4 centimeter, height of cylinder is given 2.4 centimeter, and the diameter is given 1.4 centimeter, a conical cavity of the same height means 2.4 centimeter height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. Okay. Okay, so let us see. First of all, let me draw the figure first. So suppose this is our cylinder, okay, right, circular cylinder. From this cylinder we have hollowed out a conical cavity. So when we will hollow out the conical cavity, so what we can do, right? So this type of conical cavity we can, this cavity is hollowed out, okay. So now with what we observe here, only this portion, outer portion is full, is remaining, and from inside this portion is remaining only, okay, right? From inside it is hollowed now, right? Now as a conical cavity it is hollowed, means this portion is hollowed, okay. Hopefully you can imagine what I am trying to say, right? So we need to find the total surface area of this remaining solid, okay. So first of all let us write down the key points here. Height of cylinder is given, okay. So height of cylinder that is given 24 centimeter, okay. Height of cylinder is given 24 centimeter. Then diameter of cylinder is given, diameter of cylinder that is given 1.4 centimeter. So the radius of cylinder, right, that will be 1.4 by 2, 1.4 by 2, it means 0.7 centimeter. It is the radius of the cylinder, okay. Now because the height of, now for this side I have written for cylinder, on the right hand side of this diagram I am going to write for the cone. This is for cylinder, okay, and this side, this is for cylinder and this is for cone, right? Now so the height of cone, okay, the height of cone that is same as cylinder. So height of cone that is 24 centimeter, okay. And radius of the cone, radius of base of the cone is also same as, the cylinder, so that is 0.7 centimeter, right? Okay, then to find the total surface area of the remaining solid, okay, in nearest, let me write total surface area of solid, that will be equals to, okay, you see, TSA of cylinder, total surface area of cylinder, okay, right, plus inner CSA, right, inner CSA, okay. So this is conical cavity, so that is CSA of cone, okay, CSA of cone, right. And then because this part is not there, we have removed it, this part which we have taken in total surface area of the cylinder, so we have to remove this, so that will be subtract. area of circle, that is minus pi r square, area of base, right? So that is pi r square, area of circular base. Okay, area of circular base. Okay. Okay, now total surface area of cylinder, that is 2 pi r and h plus r, right, plus CSA of cone is pi rl. Okay, and minus area of circular base, that is pi r square, right? No? So you see we are having L here, which we don't know, and L is what? That is slant height of the cone. So we need to find the slant height of the cone. So let us find slant height of the cone, and we know L is always equals to under root h square plus r square, right? So here our L will be, h is, how much h is there? Okay, 2.4 centimeter. I have written 24, it is 2.4 centimeter. Okay, 2.4 centimeter, 2.4 centimeter. So that is 2.4 centimeter square. So 2.4 whole square plus 0.7 whole square, right? So that is square root of 5.76 plus 0.49. So that is 6.25. So our L will be 2.5 centimeter. Okay. Okay, so coming back here, we can write this. I'm going to write as 2 pi rh plus 2 pi r square plus pi rl minus pi r square. Okay, so we can calculate these two, 2 pi r square minus pi r square, right? So this will be 2 pi rh plus 2 pi r square minus pi r square, that is pi r square, and then we'll have pi rl. Okay, right now let me write this r properly. Okay, so this is 2 multiply pi, and r is what? R is 0.7, 0.7, and h is what? 2.4. H is 2.4 plus pi, and this is 0.7 square plus pi, that is 0.7. Sorry, pi is not 0.7. Okay, so pi r is 0.7 and L, that is 2.5 multiply, right now. So this is when we'll calculate this one. Okay, so you see, okay, so this is 2 multiply pi multiply 0.7 into 2.4. So when you will multiply 0.7 and 2.4, we will get 3.36 pi plus 0.7, that is 0.49 pi, and plus 0.7 into 2.5 is 1.75. Adding all these, we will have 5.6 pi. Okay, and putting the value of pi, 5.6 into 22 by 7. Okay, so we will get 0.8 into 22. Okay, 0.8 into 22, that is 17.6, which is approximately because we want in nearest centimeter square, which is 18 centimeter square. Okay, so this is how you have to do.